Let's review some of the number sets comprising the real numbers. So first we have the natural numbers, also known as the counting numbers. And these are represented by a board italics N. Examples are 1, 2, 3, and so on. These are numbers used to count objects. Okay, next number system or number set are whole numbers. And although I have seen a W used to represent whole numbers, I've more often seen a board italics N sub 0 because whole numbers include all of the natural numbers plus the number 0. So I'm adding the number 0 here. So whole numbers are all of the natural numbers plus the number 0. Okay, the next number sets are integers. So integers include all the natural numbers, the whole numbers, and they're represented by a board italic Z. And they add to the whole numbers and natural numbers the negatives. So -1, -2, -3, and so on. Okay, then we have rational numbers. Rational numbers are represented with a board italics Q. And rational numbers are numbers that can be written as fractions. So for example, 1/2, 2/3, -5/3. So it can be improper fractions, and they can be negatives. If they're written as decimals, like 0.6, they are decimals that terminate. Or they are decimals that can be written with a repeating bar. For example, 1.3 with a repeating bar above the 3. So these are examples of rational numbers, but there are many more. And of course, like I said, natural numbers, whole numbers, integers, these are all also rational numbers because any integer you can put over 1 and write it as a fraction. Okay, then our next number set are going to be irrational numbers, and these are separate. So you cannot be both rational and irrational. You are one or the other. Now, I've not truly seen a representation for irrational numbers, but sometimes I've seen a board italics Q prime, meaning not Q, not rational. And these are numbers like the square root of 2, or the square root of any non-perfect square number, or pi, or the square root of 24, or 1.235178 that keeps going but doesn't repeat ever, or negative square root of 3, because these can be negatives as well. Or you might remember learning about the number e. That's another irrational number. Okay, so we've got rational numbers, irrational numbers. And then together, these form real numbers. And those are represented by a board italics R. And real numbers are all of the numbers that you see here. And real numbers are either rational or irrational. There's nothing outside of those two. They're one or the other. So I tried to make it so that the rectangles look like they were one or the other, but I did leave a little bit of space so that you could see the separation. Later on, we will talk about complex numbers, but I'm not including that here. Real numbers are a set that are included within complex numbers. So there are more number sets than are shown here.